Welcome to Leet Code Solver. Today we are going to solve 8th problem in May-leetcoding-challenge, and the problem name is check if it is a straight line. Let me open the problem. You are given an array coordinates I equals xy, where xy represents coordinates of a point. Check if these points make a straight line in xy plane. Okay, so basically we will be given two-dimensional coordinate points, and we have to check whether they belongs to the same line or not. So they are in a some, like we can, whether we can draw a straight line and using all those points or not. Here we can't draw a straight line, so this is false. So whether we have to return either true or false. And let's see constraint maximum 1000, and it can be negative as well. Okay, well, so basic idea while seeing the problem, looking at into the constraint, is that here we have if two like if we have two coordinates only, like 2 points, then definitely we can draw a straight line in between them, whether they are in like any form. We can draw a straight line, and there will be at least 2 points. If we have more than 2 points, then we have to check, like if we have 3 points, like 1, 2 and 3 somewhere. So basically if we consider the slope of the line, like if we have 2 points, we will get a slope, and if we get another point, we will get slope again. So if we keep on doing so, then like keep on finding the slope, then if the slope between the lines are same, then we can say that they belong to the same line. Like for third point, if we introduce third point, then we know the slope, like we can calculate the slope between two lines, the difference of the y and x coordinates, y2 minus y1 if we have 2 points, and x2 minus x1. This is a slope of two coordinates point, like if we have x1 y1 points and x2 y2 point, we can calculate slope like this. This is slope 1. And if we want to check whether 3 points belongs to the same line or not, then we can calculate slope 2, which is like if we introduce like third point x3 y3. So we have x1 y1, x2 y2, and we introduce third point x3 y3. If we introduce x3 y3, then slope will be y3 minus y2 divided by x3 minus x2. So basically if we keep on calculating the slope for every points in between consecutive points, then and if we have the same slope for everything, like this is some kind of some values, we can get some value if we do this calculation, which can be a floating point value. So if we found the same floating point, if we have same slope for every points consecutively, like same slope in between them, and same slope in between them, then if we keep on doing so, by including every point like up to xn yn. If we keep on doing so and we are getting the same slope, then we are done. Like we can conclude that we have the same line. They all the points belongs to the same line. So instead of doing this floating point calculation, which kind of mm, may give us the precision issues, although, so we can compare 3 points in a line together. Like if we can this the calculation by just comparing these two. If we have to say like this and this are equal, then what we can do is these two slope will be equals. If we have, we can, this should be equal. If these are equal, then we can proceed further, then we can proceed to the other lines. So otherwise we can't proceed further, and we can't do any other further calculation for another line like y4 minus y3 divided by x4 minus x3. We can't do further calculation, so let's do calculation for this line. So how can we say that these all things are equal? We can also say like by calculating double things here and double things here. Also we can do comparison by this way, like in order to be these two things equal, the multiplication of y2 minus y1 multiplied by x3 minus x2, and multiplication of y3 minus y2 multiplied by with x2 minus x1, this should be equal. If this like cross multiplication are equal, then we can easily say that slope between these 3 points, actually 3 points, two slopes are equals. If we proceed further, then if we introduce another slope as well, then we can do the same thing like cross multiplication of the difference of y and another x, and this y and another x. So in this way we can solve the problem, like avoid the floating point and precision issue. Well, we can do this. So let's begin. If we do this, then our complexity will be like just iterating over every given points. So big O of n, where n is the uh, time complexity is big O of n, and space complexity is constant because we are not using any extra space. Big O of n, where n is number of points, and space complexity is constant. Constant space complexity. Let's begin our implementation. First of all, I would like to calculate n, int n, which is size of coordinates. If we see that no coordinates, oh, given constant, we will have at least two coordinates given constant. So also in two coordinates we can draw a straight line always, so we can simply return true. Now we can start like starting from 2 less than n, like we will check three lines together. So let's say if we say that this calculation y3 minus y2 is say change in y, so dy, and this is the second one, so dy2 will be equal to current y is coordinates is a vector which have two entry per points. So current with one value minus the y just before of this I minus 1 first value, and say dx2 will be equal to same thing, coordinates I 0 minus coordinates I minus 1 0. We calculate dx2 dy2 and dx2. Let's calculate dy1, which is this one, so which will be equal to the previous and another previous y, so will be equal to I minus 1 1 minus coordinates I minus 2 1, and dx1 will be equal to same thing like previous and previous, which is 0 minus coordinates 1. So we know that if both of slope is not equals, then we can return false. So for slope this is y difference and previous x difference, so dy2 multiplied with dx1, if it is not equals to dy1 multiplied with dx2, then we can say that slope are not equal. If slope are not equal, we can return false, otherwise you can return true. Well, I think this should work. Let's compile the code. Compilation error in line number 6. Okay, yeah, we should comment out this thing. Let's run code again. False, true. Okay, there is some mistake. Where is the mistake? Let's find out. 2ni plus plus dy2 will be I1 minus I minus 2 minus 1 1 I0 minus 1 0. Yes, well, I found the mistake over here. For dx 0 is x, true. Let's submit. Accepted. All right, thank you so much for watching this video. Hope you like it, hope you enjoy the video, and if you have any different approach or anything you would like to share or any suggestion, please feel free to comment in the comment section of this video. And yeah, see you in the next video. Bye bye.